Planck's constant. Okay, so let me tell you the secret thing here, right? This graph here, the kinetic energy, remember photon equals work plus EK. But this is a graph of the kinetic energy, right? So kinetic energy is photon minus work, right? Okay. So EK is HF minus work. So this is what we're saying here is it's got a negative y-intercept, okay? And that's what this work function is. F is like x, right? This is like y equals mx plus b, right? So b is negative the work function, right? X is like f. These guys are the same, right? Okay, and then the slope of this line is Planck's constant, okay? So we use some points. What I did was I extended this using a straight edge and read that. It doesn't actually come right to there. It's a little bit beyond that, right? So I read that point, and I read that point, and I found the slope, right? So basically, what do you have? You have 4 marks. So make this argument, kind of a thing, right? Find the slope, right? Use y2 minus y1 over x2 minus x1. And that'll give you a slope. Notice that it will be in, electron volt seconds, right? Okay. And they probably want Planck's constant, not in electron volt seconds. They probably want it in joule seconds. Okay, so what you're going to do is you're going to then remember that 1 electron volt is 1.602 times 10 to the minus 19th joules minus, what would that become? 19 got like 2 ones on it. Okay, so what you're going to do, once you get that slope, multiply by this conversion factor, and then you'll get Planck's constant in so many joule seconds. Okay, there you go. You got it? That's kind of tricky, right? So you got to know that Planck's constant is the slope of that graph, and then find the slope. Then you can also convert it to joule seconds.